Welcome to this Times Techies webinar. I'm Sujit John, and I have with me my colleague Akhil George. The two of us will moderate this discussion that we are having in partnership with Western Digital. Western Digital, of course, is one of the world's largest data storage products and solutions. And today we are going to discuss the art of system design, because that's becoming central to the world of electronics. With the AI revolution, the art of system design is going to play an even bigger role in new age electronics. System design is about looking at complex systems from an ease of use viewpoint. The idea is that the complexity of the system must be buried inside different layers of the electronics and software, and therefore not visible to the customer. This provides incredible value to the user or customer because they can then focus on their tasks. To understand what goes into the art of system design, we have with us four highly accomplished professionals. We have with us Professor Mayank Shrivastava. Mayank is a professor at the Indian Institute of Science, Bangalore. He's also the past chair of the Micro and Nanoelectronics program of IISc, which in his tenure became one of the most sought after master's programs in the country. He consults with various semiconductor firms in the US, Germany, and India. He joined IISc as a faculty member in 2013. Prior to that, he held positions in Infineon Technologies, IBM Microelectronics, and Intel in the US and Germany. He has over 250 peer-reviewed international publications. Welcome, Mayank. We have Vivek Tyagi. Vivek is MD of Sales at Analog Devices India. He has been on our platform once before. Prior to Analog Devices, Vivek was the GM and business unit head at Rashi Peripherals. He was the chairperson of the India Electronics and Semiconductor Association in 22-23. Vivek has over 25 years of experience across major companies, including Western Digital, SanDisk, Motorola, Freescale Semiconductor, and Philips, which is now NXP, the part of Philips which is now NXP. Vivek started the sales operations for SanDisk's OEM and enterprise business in India in 2014. Welcome, Vivek.
Thank you.
We also have Subind Kumar. Subind is the country manager and vice president of engineering for India at Western Digital. He majorly spearheads the R&D initiatives for the Content Solutions product group and leads operations and external visibility for India. He brings over 35 years of extensive experience in the semiconductor and software industries, particularly in networking and wireless technologies. Throughout his career, he has held leadership positions at renowned organizations, including Bharat Electronics, ST Microelectronics, Motorola, and Freescale. Welcome, Subind.
Thank you.
And we also have Prasad Sandireddy. Prasad is the Vice President of Memory Technology for the Bangalore, Penang, and Shanghai organizations at Western Digital. He is responsible for the design, development of cutting-edge solid-state memory technology and product solutions across consumer, SSD, and component businesses. He has over 19 years of experience in the semiconductor industry. He's also worked on a variety of memory technologies. Previously, he held management roles at Micron Technology, US, and SanDisk in the US, prior to SanDisk's acquisition by Western Digital. Welcome, Prasad.
Thank you, Akhil. Thank you, Sujit.
So welcome to everyone. Why don't we just jump in? Subind, Prasad, maybe one of you can help us really understand system design, introduce us to it, and tell us where it is used.
Yeah, let me take, and maybe Prasad can add to this. As you know, the system design is a very wide scope. And, from our point of view, when different layers of innovation cross each other, to create a system for given application, which is for our customers or consumer can use it to devise benefit out of it, we bucket them as a system design. Prasad, you have to add something on this.
You covered that very well, Subind. Especially in our world, we deal with multiple layers of innovation before a final product is made. There are multiple, like we have flash technology, we have ASIC, we have firmware, we have software. So multiple things come together to make an end product. And that end product, the way we call it as a success by making a product that meets the requirement of customer with various characteristics derived from the customer needs itself. So we cater all of this. By the way, these innovations have to come together seamlessly to make an end product. And that's where we call it as system design in our world.
So Mayank, you want to add to that? I mean, and is that area of research and teaching in IISc?
Well, I'll put in this way. So I am affiliated with the Department of Electronic Systems Engineering. So in fact, the primary motivation of this department is to focus on anything and everything related to system design. But our perspective and view of system design is following. That at any level, you are doing certain kind of integration. You're solving certain scientific challenges, you're solving certain engineering challenges, and you're using those solutions into translating into a certain technology. The common theme or the common aspect or the common denominator of system design is that everything has to work in harmony. Everything has to, be integrated or designed or integrated in a co-designed fashion, right? Which means everything needs to talk to each other. Everything, has to be designed keeping in mind how the other aspects are designed. Whether you talk about a tiny MOS transistor of dimensions of few nanometers to large scale systems, right? Like, whether it's a memory or say a car or a rocket or anything, everything is integration of, things where everything has to talk in harmony. Now, coming back to the department and the institute, so we keep this in mind quite, I would say, religiously, precisely, and the research that we conduct and the teaching that we offer, encompasses these aspects. So, for example, when we research, we train our students, our research students, PhD students, master students, research staffs, postdocs, in such a way that they are told to be not only looking into the aspect they're trying to solve, but also various aspects which are going to be dependent directly or indirectly on these things, so that eventually the solution that they propose is really translatable to a particular application. The same when we offer our training programs like the master's program that we have either in microelectronics or system design or product design, we keep these aspects in mind. In fact, our whole curriculum is also designed in such a way that we have this kind of a training at a nanoscopic level, which is our master's in microelectronics, and then we have similar kind of training at a system level, which is master's in system design, and then similar kind of training at a product level, which is master's in product design.
Okay, so why, tell us, I mean, why are we discussing this today? I mean, Prasad, Subind, I mean, is this becoming more important? Mayank, I mean, all of you can pitch in. I mean, is this becoming more important now for India? Prasad, you want to take a shot? Okay, Vivek, go ahead.
Okay. Yeah, so Sujit, as you heard the other speakers, that system could be defined at any level from transistor to integration of multiple IPs into a silicon system, SoC as we call, or putting multiple ICs on a PCB to build a end equipment system. Why it is important today is because India is a country of youth, and youth need to be meaningfully employed in next 25, 30 years before we reach 100 years of our anniversary. And just the assembly of electronic system will not be sufficient for us to get these youth employed. So we need to create more and more jobs, skilled people into these roles who can design systems at different level. Those who are interested in semiconductor could get into VLSI system design, and others could go into building and designing systems for different end electronic equipment. Like Prasad and Subind said, from the memory or storage perspective, solid state drive could be a system. So somebody could be, learning that system development and design and manufacturing of that. And some other set of people could be putting SSD with a motherboard, with a DRAM and rest of the stuff to build a server or PC, as a system. So more and more skills and youth we have in India, available for this. We are going to do lot more value added system design, lot more value added design, and then design led manufacturing into the country. So I think that's what I wanted to share.
So,
Yeah,
Sujit, if I may have to add, if we have to spur the demand of semiconductor, it has to be through a system design. Because if you keep at the component level and just building the component, and try to replace the component which we are importing the system, and we are trying to replace the component, the demand will not get up to the level of the, where we want semiconductor to go, because unless you create a scale, you cannot create, a fab. And for all that, the necessary condition is to create demand, in our electronics for the components. And that can happen only when you start doing things from a system design perspective, and then go back to the component and, actually build those components, which is desired for a system. So in my mind, why system design is becoming important? Because this alone can drive the consumption path of semiconductor, as well as Vivek is saying, it will have a potential of employing, maximum, people and that kind of after effect because of the manufacturing and so on.
Vivek, of course, Professor Mayank also may have mentioned something about, but as of now, India's ecosystem, what kind of readiness level is it for system design? What can we do to improve it further?
Sorry, I was on mute. Yeah, so let's start with the end equipment demand in India. The electronic system design and manufacturing put together roughly at $100 billion consumption in India last year. And it's probably this year should be about $150 billion. And the government forecast and industry body forecast is it'll go to $300 billion sometime in financial year 2027. So as the India's GDP and the per capita income of our citizens is growing, so definitely demand for whether people want to own smartphone or people want to own more cars or more home appliances or more electronic system is definitely growing. Now, as Professor also said that historically all these end equipments, electronic equipment were largely imported from outside, by and large from China, but also from other countries. Last few years, there has been push and also some incentive schemes from government like PLI to manufacture these equipments in India. And in case of smartphone, definitely we can see it's happening in a big way. But again, it's largely assembly, as was discussed earlier. It is largely assembly, and the challenge with that assembly is that the value addition done in assembly is at best, high single digit percentage of margin, anywhere between 5% to 12, 13%. Now, and on top of that, government is anyway giving 5% in terms of incentive. So the real value addition comes when the country is designing these systems before manufacturing it. That's when the value addition could be as high as 40%, 50%, 30%, because then you're doing hardware system design, you're doing software development, you're also doing testing, and then you are at the control point in the whole supply chain. You decide how the architecture has to be, which components have to be done. And in that case, if there are local fabs and test and assembly, you can also fill those as was discussed. So if we have to go from now $150 billion end equipment electronic system market to 300 and eventually to maybe a 500 billion market by 2030, I think it is absolutely imperative for India to move up the value chain and develop more and more system design expertise and control of that.
Maybe we can take a bird's eye view of this. Subind, Prasad, at Western Digital, you guys make storage products that cater to a wide variety of customer needs, right? So can you walk us through how a typical product is made from conception?
Yeah. I think, as you know, Western Digital, builds both hard disk and flash storage, it's its own portfolio. And, we kind of define the system design into 3 layers, like, the underlying, the layer is the flash chip itself, which is the storage. And then we top it up with the ASIC technology, which we built it. And then the final piece of, or the final layer is firmware, So we kind of mix these things with these innovations to build, multiple storage product, of various applications, which is go to client, it can go to consumer, it can go to data storage, and so on. Prasad, you want to?
Yeah, I want to add a couple of points to it. See, we as a Western Digital are a worldwide organization, as Sujit introduced Western Digital, right? Worldwide, we do design worldwide. in each one of those components that Subind was mentioning, right? We have fabs in Yokkaichi, we have memory design in Japan, India, and other places as well, US. We have firmware the same way. So we always cater to, as a worldwide organization, cater to the customer. We always look for the value for the customer.
Professor Mayank, I just wanted to ask you, a little stepping back. I mean, we have been hearing about VLSI for many years now in India, and India is supposed to be good in VLSI. I mean, is that also system design in some ways, or is that what is it? I don't fully understand this.
Why not? So, I mean, see, when you design a system, let me put it this way. So when Western Digital designs a system, they would use a bunch of components, they integrate together. For every component, you have a library. The library will tell how the component is going to behave. And then you have a high level architecture. Within that architecture, you integrate these components, and you would have certain behavioral model which you use to kind of emulate and simulate the behavior of that system before you manufacture or fabricate and test. The same thing happens, for example, when you design a chip. Even when you design a chip, you have a bunch of components all under a library. These components and libraries are offered by the fab. So fab will develop these individual components. Fab will offer you, say a model which emulates the behavior of these components, and then you have an architecture along the lines of which you design this VLSI or the chip, and you put all the components into that architecture, and you run the system, you emulate the system, test the behavior at a simulation level, and then you fabricate or manufacture the chip, and you test it and you qualify it. So it's the same flow which is followed everywhere. Even if you build these components inside fab, where you are actually going to now integrate different elements from the periodic table, again the same thing. Every element has a certain behavior, a certain fundamental physical chemical behavior, and you know how they behave. When you integrate them in different fashion, how they will behave. You have a target specification, you have a component architecture, you integrate these elements as per the architecture, and try to design all these elements integration together in such a way that you meet the target specifications.
So Sujit, just to clarify, the AC component in our system is nothing but a VLSI, okay? Okay, that's a VLSI system, by itself. When we talk about AC, that's a VLSI system.
Okay.
But, I'm just trying to bring some complexity angle to it, and without boring anybody. See, we have a flash, that is a chip by itself, memory. Then we top it up with the VLSI, whatever you're calling it as the ASIC. And then the third top layer is the firmware, which binds these three things. So if you look at a USB flash, it might be very easy for you to look at, we just put it and copy your files. But if you break open that, you'll find these three layers into that. You're on mute,
Okay.
Sujit. If I'm able to explain to you in a way that, it's clear and, unambiguous.
Yeah. No. Makes sense.
Subind, don't forget, Flash also has VLSI. Don't leave us out, right? We also have
No,
VLSI.
that's what I'm saying. So that's what the flash is the spearheading of the VLSI, because flash is 3D today. Sujit, just to give you a context. Okay, in VLSI, we measure it by nanometers, like we are going into 7 nanometer, 5 nanometer, 2 nanometer. If you come to the flash world, we are measuring by, real estate by height. So we are calling them, 112 layers, 168 layers. So they are like, there's a more complex process, like whatever Professor is talking about.
VLSI India is good, huh? We have some good talent, is it?
Yes.
Yeah,
I'll go ahead, Vivek. I will.
So first of all, I just wanted to clarify to Sujit that when he talked about VLSI, if you take full form of that word, it's very large scale system integration. So it's anyway a system. The name itself is system integration, right? So VLSI is a system. Secondly, talking about the talent and India is good, etc., will be, I think, evident from the fact that India has roughly, this is an industry estimate, I don't have an accurate number, 150,000 or 150,000 silicon designer or VLSI design engineers working out of India, which is roughly 20% of the global workforce in VLSI design. So I think it's fairly big chunk of pie that India has today. And I think more and more talent is required in this industry. Somebody said some time ago that semiconductor is sexy again, and it is very true. Last year, semiconductor revenue worldwide was $550 billion and forecasted to go to $1 trillion by 2030. So if the industry size has to double, then VLSI design engineers size also has to double by 2030. And where else can you hire thousands and thousands of trained and skilled manpower other than India and very few other countries? So I think certainly the scope for this skill, India is already doing well in this area, but there is scope to add much more. In last few years, somehow in India, I think there was a more and more trend for engineers to look into the IT type of jobs. But I think I would say this is a role of all of us in the industry to create more awareness at the education level, and enable people to look into this as a career objective, and look into a VLSI as a skill.
So
20%, I guess IISc must be producing some of the best ones, no?
We are certainly producing some of the best ones.
We have some of them here in Western Digital.
Sure.
Not only spearheading now, Sujit, I am a little vintage, so I started in 88 in BL. Our bosses were also trained from IISc,
IISc.
those days. Okay, because those days like compound semiconductor, power semiconductor, those things like, small signal devices, we used to build in BL. Okay, so those people also came from IISc. So it maybe now it has been morphed into a new course like microelectronics system, but like as a material science, and all those courses were there. I think, I don't know, Mayank can give us more detail, like maybe 20, 30, 40 years, it is there in material science.
Let me use this opportunity, if Sujit, you allow me. See, IISc has more than 115-year history. And I want to use this platform to also educate your audience about the IISc's contribution in the larger nation building. If you talk about the current heavy electricals industry and BHEL, this originated from IISc. Talk about India's atomic energy program, this originated from IISc. If you talk about India's space program, this originated from IISc. If you talk about majority of the technologies that which have gone into defense, aerospace, missile technologies originated from IISc. The list is very long. Even more recently, IISc made significant contributions in the vaccine development. Microelectronics, IISc has, microelectronics in the microelectronics sense, IISc has a history of more than 25 years. But in terms of contributing to some of these component developments, technology, materials, IISc has a history of more than 50 years. IISc's microelectronics and VLSI design program is the most sought after program in the country today. Every student, every ECE graduate and many EE graduate too want to join IISc's microelectronics program, to an extent that, when these 50 seats that we have are filled, they join other master's program in IISc, that somehow if they get into IISc, they will have the opportunity to, to credit the microelectronics courses, because our masters are mostly flexible. So, you have a couple of core courses, mostly elective. So they would enter into many other programs and take the core subjects of microelectronics as their elective to get graduated or trained in microelectronics.
Okay, sure.
I had some different thought. Maybe I would like to
Go ahead.
have my own thought, but I would like to see if what other panel members also think about this. So, see, we have this I think I take the cue from what Vivek said, right? The last couple of years or few years, the core VLSI design, number of people taking that coursework versus the IT. I'm thinking more IT means the AI ML thing is also very, very huge now.
Yeah.
Again, this is my own way of looking at it. I think we are at that convergent place where we are not. When we were studying, it was material science or VLSI. It was core. We go deep into that subject as much as we can, and then we come into an industry, apply our skills, right? I think we are at that place where I think we also have to have this knowledge of both of VLSI. I mean, the core engineering skill plus the subject matter fact. Maybe we're not the subject matter of expertise, but how do we utilize these new skills that are out there or new technologies that are out there and combine that with our core skills? That makes a well-rounded student and well-rounded a professional which is ready to come and contribute to the industry, right? This is just my thought, but
No,
I know I can from professor and
I
others
think
to
Prasad, you are right.
right.
I think what Vivek was telling, 5 years or 10 years back, silicon become the commodity, right? So innovations were like in the software layer of the system design, and hardware become commodity. The AI ML has now again brought the focus back because now the normal processes are no more working. So we have to create new hardware, new software, new system design. So that has become more like this work of system design and VLSI and software together becoming more mainstream than the embedded software. That's the point probably Vivek was trying to hit on.
Yeah. And I'll add to what Subind, you and Prasad said, that last few years has also seen emergence of some of the top electronics company in the world getting into semiconductor design for their own. That's, I think, making a comeback for semiconductor in a way, whether it's a career point of view or otherwise as an important aspect of industry.
Professor, you want to
Thanks, Vivek.
what Prasad was saying?
I was just agreeing with what Vivek was saying. Yeah, I'm of the same thought.
Maybe I'll
So what? Please continue. Go on.
so where I completely agree with Prasad, but the way, for example, I think this is the change that we have to bring in the country. So I would divide the educational system or the education system in the country in three different tiers. Not that I want to use tier terms, but somewhere we have to put a distinction. Tier one, where I would say institutes like ISC and some of the top IITs. Tier two would be the other centrally funded institutes where they are very good in undergraduate programs and they are catching up on research. And tier three, where the focus is primarily on the undergraduate programs. Now, if you look at institutes like ISC or say some of the other top institutes like IIT Bombay, the focus is, the way we train people is quite flexible. So there's a certain core training that we offer. Even in the microelectronics program, we offer a certain core training, which is mandatory. But then there's enough scope for people to branch off into other areas, which are through electives. So 50% is mandatory and 50% is elective. And through these electives, then students are allowed to pursue their interests. Somebody might be interested in pursuing, say, communication for VLSI or VLSI for communication. Somebody might be interested in pursuing, say, looking into neuromorphic hardware and implementing, using VLSI principles for building neuromorphic cores or neuromorphic hardware. Somebody might be interested in, for example, getting more in terms of more towards materials. Somebody might be interested in getting into quantum devices and quantum technology. Somebody might be interested in, becoming an experimentalist and get hands-on on a lot of sophisticated process and characterization tools and develop skills in that direction. Somebody might be interested in, becoming somebody who can build theoretical models for these components or systems, right? So we offer that kind of flexibility. So when we train them, there's a mandatory course, and the electives are chosen based on the branch, the kind of vertical they want to pursue, and then they're additionally offered kind of a research project, 1-year research project, which further helps them to kind of become an expert in that direction. But when we go to places like, to an extent tier 2 and tier 3, the training is kind of, very set. It's a curricula driven. In fact, one of the term which was used earlier, curricula. So in ISC, we don't have a, very hard, tight curricula. Whereas if you go to some of these other places in India, the curricula becomes, strictly defined, and therefore there's no flexibility for students to kind of, explore anything other than what the curricula tells. Now, this is something which has to change. I understand that, when we talk about tier 2 and tier 3, we are talking about a bigger mass, and solving a problem at that bigger mass and having that many faculty who can offer this additional flexibility, right, is a bigger problem. And I think this is where industries can pitch in. If industries can start, and again, there the curricula is driven more by the universities where these institutes are affiliated. So in industries cannot talk to every institute, but if industries can start talking to universities and start giving them feedback that, okay, can you make your curricula a little flexible? Can you bring in these aspects in your curricula? Right? I think this will be the first step towards changing the way the tier 2 and tier 3 train their students, and bring them at least somewhere close to how the training happens in tier 1. In tier 1, of course, everyone, as I said in the beginning, that 5% of our time is teaching and 95% of our time is research, and whatever we teach is all derivative of our research. So in that way, there's enough to offer to teach, because there's so many people working on so many threads. Everyone has innovative things happening in their lab, so there are enough things to offer in terms of teaching. But the same doesn't happen at that tier 2 tier 3 level. That is where the industries have to pitch in, offer this feedback to universities, and tell universities that, can you bring in these additional flexibility, these additional components on your curriculum, maybe as an elective, maybe as a soft core. But until unless that doesn't happen, you will see a big difference between the students are trained, and that big difference will lead to the kind of the gap, the manpower gap that will eventually happen when at some point, as Prasad mentioned, that you need people who are, say, trained in some core, but also trained in many things around it.
You have to take the courses in software, in electronics, in materials, and combine them together. People are very comfortable in the silos. Now, tell me how to do a firmware design. I'm a specialist in firmware design. I'm a specialist in material. So,
So how do we change this? How do we change this, Subind? India's academic institutions, especially the tier 2, tier 3 ones.
So the point, this is where, to start with, as the people whom we are going to hire, or we have to show them in the way, that how system design, thought process can, bring a wider scope for them, and they can build their career even better when the system, they work in a wider area rather than a constrained area.
So what's your advice for students then, to take an interdisciplinary approach to engineering at its heart? Is that it?
I mean, first of all, yes. I mean, the computer science people who are good in coding, they need to know the digital design. And I'm sure people are doing it, but they don't pay a lot of attention in the third year or fourth year. They just go on to, write all the software jobs, exams, and they forget the basics of digital design. Whereas, in the whole stack of the things, we need digital design, analog design, materials, as well as software.
Yeah, Can I add? Okay, go ahead, Mayank. Go ahead.
So, see, one thing I can tell you, the one effort that we recently started, and it is now called India Semiconductor Workforce Development Program. The vision of that program is that, can we reach out to the undergraduate students? I mean, though the program is open to all, but including industries, but can we primary or target is undergraduate students? Can we reach out to undergraduate students, offer them a certain training which can inspire them? So twofold. One is to inspire them to pursue higher career in semiconductor, and second is to help them connect dots with whatever they see in real world, whatever they see in textbook. Usually what happens, particularly semiconductor is a field which at an undergraduate level becomes very difficult to understand. If you think about these undergraduate students, they are often inspired or fascinated by things that they see in their daily life and things that with which they can connect to. For example, in the older times, it used to be coding, that they can, okay, we can code and you build all kind of softwares. Very, very nice. Then in the more recent time, it's AI, that okay, if I learn AI coding, or I can build these kind of interesting AI systems, a human machine interface. I mean, the extrapolation is big. The extrapolation drives their imaginations, and then they are kind of fascinated towards those extrapolations, even if they are, they will not be able to work on those extrapolated topics immediately after undergraduate. So then, we thought that can we build a similar kind of imagination at an undergraduate level in the field of semiconductor, where it is very difficult. I mean, you start with quantum mechanics. Imagining quantum mechanics, particularly at undergraduate level, becomes, one of the most difficult topic. So can we offer a certain training program, for say 3 months to a larger audience, including undergraduate students from all range of colleges, and help them connect dots with what they see in textbook, help them understand how industry develops the entire thing, train them to a certain basic level that they're not even ready for, for say entry level positions within semiconductor fabs, but also, feel inspired to pursue a higher career in that field. So this is one effort that we started, for example, in semiconductors. Now, system design is equally challenging. System design, at an undergraduate level, you read, you learn different subjects, but it's very difficult to connect dots. It's very difficult to understand that, okay, I learn about electronics design, I learned about op-amp design, I learned about communication system, I learn about analog communication, I learned about digital communication, I learn about electromagnetic theory, I learn about maybe ATM design, I learn about antenna design, but I have no idea how do I use all of this in building a larger system. Now, this is where, either institutes like ISC need to pitch in, or industries like Western Digital need to pitch in, where you offer certain kind of, it may not be a 3-month training, it may not be a 1-month training, but even if it is say a few days workshop offered to a larger audience, right, undergraduate students, so that they at least understand the entire flow of system design. They understand, what all is involved in system design. They understand that what all they learn at an undergraduate level, how that fits into eventually building a larger system. I think that will be a big service to the nation and big service to these undergraduate students from tier 2, tier 3 places where they don't have that kind of exposure.
Exactly. So I think, Sujit, just to make few lines on this, that is where the internship program, we don't do, we always do internship for 6 months, because 1-2 months internship is kind of, no,
you do
what,
that, is it? Internship, I was
yeah,
about to ask you.
yes, we get, religiously, we get people in January, train them in June, and then hire them until July, and so on, So that is, as Mike is talking, this will be a great segue for people to understand system design, and then go and, do some part of it, and then again, they are able to understand, how it is connected, how the dots are connected. And this is how we are building our workforce. We are kind of hiring our workforce, training them like that.
The new generation, they're much ahead than when we were at the same level of coming out of university. So credit to them. They're well informed. They're well connected. They know what is happening across the ponds, across the bridges. They know what's happening the research wise. They're well informed of things that is happening in the world. So the students are, I mean, they always surprise us. In our company at Western Digital, we see people joining us within 6 months. They file patents as well, worldwide. It's not just India I'm talking about, worldwide, right? So there's bright minds out there, but I mean, it's a cliche to say, but we have to be curious. Whatever specialization you are pursuing, you do that well. You have to do that well because you have to graduate based on that mark sheet that you will get, right? You have to do that well, but be curious. Make sure that have a right network. You have a group of people. One of my mentor used to say, don't don't ever have lunch alone, and always use that for networking moment, right? One of my mentors used to say, and that today works a lot. Same thing, I'm gonna give it back to the students. Don't have, if you have a time, don't talk in the same curricula or same place. Go mingle with others. You would know where are the other. The innovation always happens where we come together on the edges, right? So that's where I would say students be curious. We have internship program, not just Western Digital. Many companies do that. If whatever is right for you, get in, learn, and then apply those the skills that university and academia gives you theoretically, and use that in a practical world, right? So
yeah, Vivek.
Yeah, Sujit, see, we heard earlier also that most of the university to which standalone government or private colleges are affiliated don't have flexibility. They have fairly rigid syllabus or curriculum. So this for students having flexibility to learn different interdisciplinary skills is not easy because there's no flexibility. So one thought that I got while listening to all the other panelists is that especially the tier 3, as we discussed some time ago, if students coming out of those colleges, if they are not fully industry ready in VLSI system design or the electronic system design, we have to think about a 6 months to 1 year bridge course. We talked about a workshop, but workshop is more like enlightenment to this field, that this career option is available, this field is also available, you need to develop some skills. But if they need to be employable in the industry, they have to go through a 6 months to 1 year program, and two type of program have to be defined. One, VLSI system design, other is embedded system design or electronic system design. And these could be developed by either ISCs or IITs or triple ITs. And initially they can teach one batch, and then subsequently they can teach other engineering colleges professors, and then it has to fan out to multiple colleges throughout India to create this more industry ready skilled workforce for us to scale up in this system design world in the next 1 decade or so.
Okay, we had a good discussion on that part. Vivek, staying with you, I mean, just to change track a little bit, the PLI scheme, is that impacting the system design side of it? I mean, across the value chain, I think the government has proposed various PLI schemes. System design is also part of it, or?
No, so PLI scheme stands for Production Linked Incentive Scheme, which basically says to any global or Indian company, if they wish to manufacture an electronic system like a smartphone. So there's a PLI for mobile phones, there's a PLI for home appliances, there's a PLI for different industry vertical. Like now there's a PLI for telecommunication equipments also. So PLI is essentially encouraging or incentivizing industry to manufacture that set of equipment in India, and if they meet their stated goals of production of certain type of equipment in terms of value, then they get a 4%, 5%, 6% cashback incentive of government as specified in PLI. But PLI itself does not state anything that equipment has to be designed in India. It is more about manufacturing, which is mainly assembly.
Isn't there some design link scheme as well?
So there is a different scheme which is called DLI scheme, Design Linked Incentive Scheme, rolled out by MIT, whose primary objective was to encourage Indian semiconductor startups who can think of doing a semiconductor design from India, and then they have a lot of cost in terms of licensing design tools, VLSI design tools, and also spending for salaries and other infrastructure cost of office. So DLI scheme basically calls for application from these companies, and if selected, then they can get 50% reimbursement in terms of your office and staff salary for a certain period of time. And government also actually bulk purchase some of the chip design tools which are available in their common cloud, which are accessible to these DLI scheme qualified companies to access. So that's a slightly different scheme, but it's not so much, in my opinion, today focused on the end equipment system design. It's more on the semiconductor design there.
Okay.
Yeah.
I agree, Vivek. I think in a small way we do that back in US, where we have our HDD media factory there, where we have some tools, which is our research lab, and those are actual tools, I mean, not research like an engineering tools, actual tools, where some of the startups or even the academia people can apply, and we give them a slot where they can come and their prototypes, they can make it there and go measure things. So that work, wherever we have possibility, we are doing it.
Okay. I know we are almost running out of time. Akhil, any last question?
Maybe everyone could just mention how, just quickly mention how AI is going to help maybe all of the next generation become design scientists.
Yeah, I think great question, Akhil. I'll take it from where Vivek is starting. Like right now, the prototyping is very prohibitive, expensive. This beyond reach of startup and so on. So there are ways and means to use AI ML techniques first to cut down the design cycle, development cycle for these kind of system design. Okay. And the second is to prototype them also. We need to get it more cost efficient and not have to build through this whole structure of mask and, which is like tens of millions of dollars and, a slot in a foundry, which is very expensive. So not only shorten the cycle of the system design, which, like a professor was talking, 8 to 10 years, the prototype cost is also going to, go through a new paradigm shift where we don't have to build, these prototype actual physically and, test them. There will be some methods and, the way we are testing things and, and do prototype, So I think these things are going to take its, what do you call, how to call, like a new turn, an inflection point in terms of design and prototyping of the system which we are talking about today.
Inflection point in design and prototyping. Vivek, you agree?
I do agree. We already see that a lot of AI ML is being used in the VLSI system design, and especially on complex chips, where routing and putting the layout is being done using AI tools, where the cycle time is drastically reduced. Another opportunity, because I'm representing analog device here, is a slightly adjacent opportunity. See, AI ML, all the training is happening from the data center by putting these GPUs on the servers. And these are power guzzlers. So today's data center is consuming 5% of world's electricity. But by 2030, data centers will consume 10% of electricity. And these are very high, like thousands of amperes of current. So we as a company is also seeing how to have more efficient power supplies and power products designed to take care of these data center power systems. That's another adjoining opportunity in the AI ML space.
Okay. Prasad?
Yeah, being from data storage industry, I will say that, AI is critical to storage and storage is very critical to AI. And as Subind and Vivek said, we are already utilizing AI and ML in our design cycle.
Okay. Professor Mayank?
See, in any design cycle, the maximum amount of time that is taken is by optimization and verification. Now, both optimization and verification can be handled very well by AI models and AI tools, and later on AI models with the LLM integrated together. So in my view, and this is something I was also telling in my class recently, that very soon most of the optimization jobs and the verification jobs will be taken over by AI based tools. But the other catch is that if you look into the job market, majority of the jobs, when Vivek tells that 150,000 VLSI engineers are there, majority of them are involved in optimization and verification.
Really?
Even more are involved in verification than optimization. So you also be prepared that the number of jobs or the VLSI verification engineers out there, that will come down. Of course, the number of products will grow, the market is growing, so the requirement will grow, but I think effectively the number of verification engineers in the market will come down, and
Can you upskill them? Can you upskill them to system design and stuff?
Yeah,
you can upskill them, but for example, today, whatever is done by 10 verification engineers, with a lot of scripting and automation, the same thing can be done by one verification engineer with an AI tool in the backend used. So that is also going to come down. So we have to be prepared for that kind of a job cut.
Okay.
Sujit, the productivity jump is kind of, fuel the, demand, I mean, like
And
creation, the supply side, and that will, match the demand. Demand is also growing. It is not that, like as Vivek was talking, the $1 billion on the chip is growing, system is growing. So it is, we are in a midst of like a dream run, in terms of electronics design and system design. So what I feel is this productivity bump will spur more products, and more innovation, and that can be like used, for betterment of the humanities, customers, whatever. So in summary, I would like, say that, that this AI/ML thing is going to give a jump on the productivity, but we are not going to lose the manpower. We have to get the manpower. We have to use the manpower for something which is more meaningful. So Sujit, I'll just add one line, like as Professor is saying, like how to address the intellect thing, whenever, as Prasad was also talking, whenever the interface of the layers are there, like more intelligence is required, where, AI/ML will not be able to handle that interface. That interface, that design interface, that optimization has to be done by a human thinking right now, as per whatever knowledge we have about AI/ML. We don't know 5 years from now how it's going to manifest.
Okay. Professor Mayank, your batch size of 50, that can't be increased, no? Even though people have elective options and all that, that requires more faculty and all that.
Yeah, we have plans to increase, but the industry has to pitch in, because this batch has the numbers are limited by the funding that we get from the government. The numbers are limited by the number of hostels we have. The numbers are limited by the space in the lab and the classrooms we have. And if at some point, if we have to increase the number, eventually we increase the number for the benefit of industry. And if we have to do it for the benefit of industry, then industry has to pitch in into, whether offering the scholarship, offering them stipend so that they can have a place to stay, offering, setting up labs within the institute so that we can accommodate more and more students. So I think industries need to come together and help us expanding our infrastructure and the amount of funds that we have to support these students so that we can grow these numbers from, say, today 50 to 100, or maybe even beyond.
Okay. So yeah, massive electronics demand expected. India, of course, is trying to build a big semiconductor and electronics ecosystem, trying to build fabs. And absolutely, system design is going to be crucial to this entire process. It requires multidisciplinary skills, and a whole lot needs to be done to build this ecosystem. Webinars like this and coming together of industry and academia will be a great step forward. And as all of you said, I think all of us need to work together to build this ecosystem so that India can, not be so dependent as we are right now on other countries for something as crucial as semiconductors and electronics. Yeah, Mayank, you want to.
Last thing I want to add, and which is the role organizations like Times of India can play, is helping country with the brain drain issue. So the students, the younger generation, are not much aware of the opportunities which are available in the country or which will be available in the country. Their parents are not available of the opportunities which are available or which will be available in the country. The younger generation and their parents are not aware of how the academic institutions like ISC have grown, and what kind of research happens here, what kind of training happens here. Not only ISC, but other similar academic institutions as well. As a result of that, what happens, the general mindset among the middle class, majority in the middle classes, that, or upper middle classes, that an education abroad is a safer area, safer approach, right? I mean, today affording a loan is not a big deal for upper middle class. Now, if they're aware that they can get the same kind of training, education, and similar opportunities in India, right? They would possibly, many of them would possibly not be willing to leave. Many times these things are driven by their parents. The parents need to be educated more than the younger kids. And this is the forum where I think agencies like Times of India can play a very important role. So you need to publish more on the science and tech and the education and the opportunities and the industry and the entrepreneurship in India, over and above the pages that you have for politics.
Totally agree. Totally agree with you. In fact, this page called Times Techies that we bring out twice a week across the country now, the big reason is that, and we have a big focus on careers and on the opportunities in India. And I remember about a year ago, or a year and a half ago, when the entire conversation around semiconductors, building that ecosystem, those PLI schemes on all were happening, we were doing a lot more of semiconductor stories. There's been a bit of a lull lately. Big focus on AI, ML, and stuff. Everybody seems to be talking only AI right now. But more than happy to. We would love to have a lot more discussions on semiconductors and systems design and then entire electronics ecosystem. More than happy to do that. And absolutely, like you said, we have to stop people from going overseas for all of these opportunities.
Even beyond. I mean, beat it computer science, beat it mechanical engineering, beat it pharmaceutical, beat it biological sciences, physical sciences, whatnot. I mean, there's so many opportunities present in the country, and their students and their parents need to be aware of.
Totally agree with you. Totally agree with you. So, I mean, that's actually the reason why we brought out Times Techies. I mean, it's now 5 years now, but like I said, sometimes certain topics tend to take precedence over others. But yeah, totally agree. So thanks to all of you. We really had a great discussion on this whole ecosystem. And like all of you said, system design is becoming absolutely crucial, and we need to really build that ecosystem. Thanks, Professor Mayank, Vivek, Prasad, Subind. Really nice having you, all of you. Thank you.
Thank you for having us. Thank you.
Thank you, Prasad, Subind, for inviting us.
Thank you, guys.
Thank you.
Thank you, Professor. Thank you.
Bye.